Hey there. Welcome to our channel. We're so glad you're here. Please like, share, and subscribe to join us for awesome content. Also share this video with your family and friends. Let's get started. Whispers from the void. You lie still, surrounded by the hush of night. The air is soft against your skin, and the weight of your body gently dissolves into the quiet beneath you. You are here and yet not quite. Your mind begins to float, slowly peeling away from the now, slipping backwards in time, deeper into the dark. With each breath, the universe rewinds. The stars you know begin to vanish, unforming like dew at sunrise. Galaxies contract inward, like the slow folding of celestial wings. Time folds gently, peeling away its layers. The sky empties, light retreats, and then nothing. But it is not a frightening nothing. It is the silence before music, the blank page before the first word. The universe, curled tightly into a singularity, impossibly small and impossibly dense. And in that instant, so quick it has no name, everything begins. There is a flash not of color, but of being. Not an explosion, but an unfolding. A release of energy that floods into time itself, expanding, cooling, blooming outward like a great cosmic sigh. You are drifting now through this first breath of creation, the Big Bang. In this newborn space, particles flicker into existence like sparks from a fire. Not one at a time, but in pairs. A particle and its reflection. Matter and antimatter. For every electron, an anti-electron. For every proton, an antiproton. They are perfect opposites, yet born as one, twins emerging from the same cosmic cradle. You imagine them. Tiny, dancing partners in the void, each spinning in elegant balance. Matter and antimatter, like mirrored flames. Identical in mass, but with charges reversed. If matter is a mountain, antimatter is its valley. If matter is the outward ripple, antimatter is the inward pull. The universe, in its earliest moments, is a ballroom of symmetry. Everything has a counterpart. Every push has a pull. Every creation, a reflection. And then, one by one, they vanish. These partners, so delicately paired, meet and embrace. But in their meeting, they do not remain. They disappear, collapsing into pure energy. Light, heat, radiance. A billion pairs born, a billion pairs gone. What remains is not what should have been. A whisper too many of matter, a whisper too few of antimatter. You drift through this imbalance now, as if wandering through a fog of unanswered questions. Why did matter win? Why are you here made of atoms instead of light? Why are the stars made of substance, and not of its mirror? The scientists call this the matter-antimatter asymmetry, a riddle wrapped in silence. According to the rules, both should have destroyed each other completely. The universe should be empty, only light, no form. But you are here. Your hands, your lungs, the atoms in your bones, are evidence of a small, unexplainable preference. Somehow, for reasons still unknown, the universe chose matter. Or perhaps matter got lucky, and so the cosmos moved forward, built upon imbalance. But buried deep in its early memory is the presence of what could have been. Antimatter was real, is real, though fleeting, though rare. It is not a fantasy. It is not fiction. Even now, in this time so distant from the beginning, particles of antimatter still whisper into being. In high-energy places, within thunderstorms, in radioactive decay, in the hearts of distant galaxies, antimatter flickers like embers. The dance continues briefly, before vanishing again. You feel this ancient rhythm beneath your skin. Every second, your body is visited by neutrinos and cosmic rays, tiny travelers from the beginning of time. The universe is not still. It breathes around you, through you. You are part of its long memory. And in that memory, there is symmetry. A lost reflection. A partner that was almost yours. You wonder now what it means to exist alongside something so similar, yet so dangerous. Matter and antimatter cannot touch without disappearing. A kiss becomes a disappearance. A handshake, a flash. What a delicate metaphor for life itself. How close beauty and destruction truly lie. Imagine holding something in your palm that cannot be held. Imagine trying to build with it, to store it, to use it. Antimatter is both promise and impossibility. It holds the key to vast energy, and yet slips through our fingers before we can dream. But still, the question lingers in your mind. If it can be made, even in glimpses, could it one day be caught? Could we shape it, use it, turn it into fire or flight? You breathe slowly. The night deepens. The universe, still expanding from its ancient origin, carries you forward on its tide. The symmetry has broken, but the memory remains. You began this journey in the void, where opposites were born in equal grace, where silence cracked open and light poured through, where matter found a way to remain. But what of antimatter? It has not vanished entirely. It still waits in flashes, in laboratories and collisions, in ideas and dreams, in the minds of those who dare to wonder. And as you drift further into sleep, your thoughts settle on a single quiet question. If antimatter is real, if it exists in our world, even for a heartbeat, what form might it take, if we could find it, and hold it, just long enough to see it shine? Shadows with mass, you lie suspended in quiet thought, your breath soft, your body sinking into stillness. Outside, the world slows to a hush, but inside, deep inside, you begin to float again. The stars fade behind your eyelids, and the universe folds inward. You are not alone. You are surrounded by invisible echoes. Imagine now that you are looking into a mirror, not the kind that shows your face, but one that shows your substance, your very particles. And in that mirror there is another you, not made of imagination, but of something real. Something just as structured, just as solid, but built in perfect reverse. This is not fantasy. This is antimatter. Somewhere, a positron pulses into being. You feel its presence like a faint warmth in the air. It is the twin of an electron, same mass, same spin, but with a heart of opposite charge. While electrons spiral with a negative hum, positrons shine with positive light. You drift closer. You are inside a thought now, a space between knowing and sensing. Picture the tiniest drop of existence, a hydrogen atom. In your body there are trillions, each made from a single proton and a single electron, bound in a soft electric hug. Now imagine the opposite, an antihydrogen atom, a positron and an antiproton circling each other, just as stable, just as precise, but never found in nature's usual toolkit. Like a shadow drawn in light. And yet, it exists, not in your kitchen, not in the sky, but deep beneath the earth, in vast circular tunnels lined with magnets and silence. Scientists coax these mirrored atoms into being. At CERN's antimatter factory, they slow down particles that should not stay. They trap them in invisible bottles made of magnetic fields. And for a moment, just a flicker, antimatter lives. You might ask, why does it not stay longer? Why can't we build with it, store it, cradle it like we do matter? The answer is simple and strange. Antimatter cannot touch matter. Not even a whisper. The moment they meet, they vanish. The meeting is so complete, so final, that nothing is left but energy. A small flash, a quiet burst of light. So we must trap it, hold it at a distance, like catching sunlight in a net made of shadow. We keep it alive in vacuum chambers behind layers of technology, for a few seconds at most. And then, it's gone. You feel a softness in this truth, a humility, that something so perfect, so symmetrical, can exist only in absence, only in careful separation. But even with its fleeting life, antimatter leaves behind evidence, just enough for us to understand that it is not just theory. It is fact. It is substance. It has mass. Think of that for a moment. Something invisible, fragile, untouchable, yet with weight. Positron, for instance, is created all the time in this world. When a banana ripens, when a radioactive mineral decays, when lightning crackles through the sky, positrons appear. Briefly, quietly, and then, as always, they vanish in a soft exchange with their opposites. Even in hospitals, you are closer to antimatter than you might think. In PET scans, positron emission tomography, doctors use tiny amounts of radioactive substances that emit positrons inside the body. When those positrons meet electrons in your tissue, they annihilate, producing light that we can see with special cameras. That light becomes an image. That image becomes diagnosis, healing, insight. You are surrounded by shadows with mass. They are not fiction. They are not far. And yet they are not ours. You imagine now holding one of these particles in your hand. Not as fire, not as weapon, but as wonder. A sphere of potential. A question made real. What could we learn from such a thing? What stories could it tell? But perhaps the story is already around you. Your own body hums with particles that carry memory. Carbon forged in stars, oxygen breathed by trees. You are made of matter. But matter is not the only possibility. There is a beauty in knowing that every particle could have had a twin. That for each atom in your body, a mirrored version might have danced in another possibility of the universe. Why did your version stay? Why are you here, and not your reflection? You breathe in the silence. The question drifts like smoke. Some say the universe is biased, that a tiny imbalance in the early laws of physics tipped the scales in favor of matter. Others wonder whether entire regions of space, maybe even other universes, could be made entirely of antimatter, forever separated from ours by space, by charge, by fate. Would such a place look different? Feel colder? Or would it be identical down to the stars, the planets, the pulse of a heart? You rest with the thought, not in fear, not in urgency, but in awe. Antimatter is not just the stuff of bombs or spaceships or cosmic riddles. It is the echo of symmetry, the reminder that even reality has a mirror, and that sometimes the mirror is just out of reach. You are drifting again now, following the curve of the idea, the rhythm of matter, the hum of opposites. There is no need to grasp it tightly. Just let it be. Tomorrow we will wonder what happens when these reflections meet. What becomes of their union? What light is born when two perfect shadows dissolve into one another? The delicate annihilation the night wraps around you like a soft cocoon. Your breath slows, matching the rhythm of the world's quiet pulse. Outside, the stars remain steady. Inside, your thoughts return to the strange companions you've met. Matter and its silent reflection, antimatter. Now you drift toward the space where they meet. Not with a crash, not with violence, but with a strange and perfect stillness. Two particles, an electron and a positron, draw close in the vastness. They are not enemies. They are not even strangers. They are mirror twins, shaped by the same laws, carrying opposite charges, pulled together by a quiet, invisible magnetism. And when they touch, they do not clash. They vanish. In a single instant, both are gone, no debris, no fragments. Only light remains. Flash. A pair of photons, born from their union, rushing away in opposite directions at the speed of all that is. This is annihilation, a word that might sound harsh or even terrible. But in truth, it is simple, precise, almost gentle. There is no explosion, no violence in the moment itself, just the transformation of mass into pure energy, governed by the deepest rule of the universe. E equals mc squared. Mass becomes energy, form becomes light, and light is never lost. You imagine this now, not as something distant or abstract, but something real happening all around. In cosmic rays striking Earth's atmosphere, in the center of our galaxy, where matter and antimatter swirl in silent spirals. Even in your body, when a PET scan is performed, where each burst of light comes from a tiny act of annihilation, captured and turned into meaning. So much from so little. A single gram of antimatter, if combined with a gram of matter, would release enough energy to power a city. Not from burning, not from fission, but from the complete conversion of mass to energy, a process more efficient than any engine humans have ever built. You are holding that thought in your mind now, a process so powerful it defies scale, yet so clean, so mathematical it leaves no trace behind. Annihilation is not destruction. It is transformation. And this idea, this quiet, miraculous idea, has caught the attention of dreamers and scientists alike. What if, they ask, we could harness this process? What if we could store antimatter safely, deliver it to matter in controlled ways, and extract energy from the meeting? Could we power starships? Could we design weapons? Could we unlock a future shaped by light? But you pause here, not to run ahead into dreams or fears, but to rest in the heart of the idea itself. Before application, before use, there is simply the fact that matter and antimatter contain immense energy, not in their motion, not in their heat, but in their very being. Energy is not a thing added to matter. Loving this? Hit that subscribe button to keep up with our videos. Also share this video with your family and friends. It is what matter becomes. And so, as you drift through the thoughts of particles and photons, you begin to see the universe not as solid and separate, but as waves and transformations. Things shifting from one form to another again and again. Stars into dust, dust into people, people into memory. This annihilation, then, is not a tragedy. It is a release, a moment when two forms meet and become something greater, light without weight, without edge. You remember, too, how carefully this process must occur, how delicate it is. One misstep, one touch out of place, and antimatter vanishes before it can be used. That is why, even with all our machines and knowledge, we create only minuscule amounts. We store it with magnets and vacuums. We measure it with care. Because in every moment of annihilation, there is both a loss and a gain. Something disappears, but something else is born. A photon, a wave, a ripple in space. And perhaps that is a metaphor for more than physics. You breathe deeply, gently rocked by the rhythm of the thought. How often do opposites meet in your life? Ideas that conflict, emotions that collide. And yet, when they do, when you let them touch, sometimes clarity is born. Not destruction, but understanding. Not conflict, but illumination. Like light from the center of a vanished particle. You feel a calm humility in this law of nature, that opposites do not always fight. Sometimes they complete each other. Sometimes they vanish into beauty. And yet, you wonder, could we ever control this? Could we scale it? Could we build with it? If annihilation releases such energy, what would it mean to harness that energy, to trap it, shape it, use it as fuel? What would it take? You lie still, imagining scientists working late into the night, adjusting magnetic traps, simulating reactions, watching beams of particles collide at near light speed. They are chasing a flame that disappears before it can be caught. Antimatter does not want to stay. It is the butterfly of physics, brilliant, rare, and impossible to hold. But the potential remains. Even the tiniest trace of annihilation holds a hint of promise. And that promise hums in the minds of engineers, dreamers, even soldiers. Because if this process can be mastered, it may one day power great machines, or terrible ones. You pause again, not to fear, but to feel the weight of that thought. The double edge of energy, the fine line between progress and peril. But tonight you stay with the wonder, not the use, not yet. You end where you began, in the quiet meeting of opposites, the soft surrender of substance into light, the breath of a universe that remembers both sides of itself. And as you begin to drift into deeper rest, the question remains, like a gentle breeze stirring the edge of sleep. If 1 gram holds such power, could we ever gather it, shape it, store it? And what would that journey look like? A teaspoon of stars, you drift deeper into sleep, your body wrapped in softness, your breath slow and smooth. The world around you fades into shadow, but your mind is still moving, calmly, curiously, across a landscape of possibilities. You're holding a teaspoon now, just a small one, smooth metal, cool to the touch. But this isn't an ordinary teaspoon. It doesn't hold sugar or salt. It holds antimatter. And in that tiny silver curve, barely a mouthful, rests the energy of 1,000,000 tons of TNT. Enough to power a city. Enough to launch a ship to the stars. Enough, perhaps, to change the course of history. You're not afraid. Not here. Not in this gentle place of wonder. You are floating in imagination, wrapped in the light of quiet stars. And so you ask softly, could it ever be real? Could we truly hold such power? Let's begin with what's known. A single gram of antimatter, just a paperclip's worth, contains energy equivalent to 43 kilotons of TNT. That's more than 3 times the energy released by the atomic bomb that destroyed Hiroshima. But the beauty of antimatter is not only its power, it's its purity. No smoke, No fallout. No chain reaction. Just the clean, complete conversion of matter into energy. A final act of transformation. One that Einstein's simple equation, E equals mc superscript 2, quietly predicts and explains. It's not fantasy. It's physics. And so, for decades, scientists have dreamed. What if we could build an engine powered by antimatter? What if a spacecraft could be pushed forward by bursts of annihilation? Pure energy, focused and clean. You feel the shape of that idea forming in the dark. A ship, sleek, silent, glowing with purpose. Not fueled by fire, but by light itself. The antimatter drive, still theoretical, would release particles in controlled streams. The energy would be immense but manageable. Propulsion without burning. Speed without friction. The stars would no longer be unreachable. You float beside that ship, watching it pierce the void. A trail of invisible power stretching behind it. A new kind of journey, born from balance and annihilation. But dreams meet limits. And here, the calm edge of possibility appears. Because making antimatter is not easy. In fact, it is extraordinarily difficult. We do not find it lying around. We create it in particle accelerators, where protons smash together at incredible speeds. For every billion collisions, only a few antimatter particles emerge. And even then, we must trap them. Hold them in magnetic cages, suspended away from matter, in vacuum and cold. It's like catching fireflies in the wind, if the wind was space and the fireflies exploded on contact. Today, all the antimatter ever produced by humans could not fill your teaspoon. In fact, it wouldn't even fill a grain of salt. And the cost? Astronomical. By some estimates, producing 1 gram of antimatter could cost upwards of $1 trillion. And that's just production. Containment, storage, and safety would add layers of complexity. You breathe in slowly, absorbing this paradox. We have glimpsed the power. We have created the spark. But we cannot yet gather the flame. Still, the image lingers. A teaspoon of stars. A symbol of what might be. In your mind, it becomes more than a tool. It becomes a metaphor. A reminder that even in the smallest things, just a gram, just a second, there can be immense energy, unimaginable transformation. And isn't that true in life? Quiet word can change a heart. A moment of clarity can shift a lifetime. A single act can ripple across generations. Energy is not only in reactors and machines. It lives in choices, in relationships, in wonder. Back in the world of science, researchers continue to dream. Antimatter could one day be used to ignite nuclear fusion, acting as a perfect match to light a much greater fire. Or to power deep space probes that would otherwise run cold in the endless dark. There are designs on paper, engines imagined, labs testing containment rings, lasers, magnetic fields. The work is slow, methodical, but it is happening. Not for weapons, not only, but for exploration, for discovery. You float now in that dream, a slow-motion vision of human progress, not rushed, not loud, just steady, hopeful, real. We are learning, bit by bit, how to hold something that vanishes. You imagine the future 100 years from now. A facility deep underground or perhaps in orbit, producing antimatter in faint, glowing streams. Technicians in silence, watching containment fields pulse with trapped reflections. A teaspoon full at last. What will we do with it? The question is not just one of technology. It is a question of purpose. Because antimatter is not just energy. It is potential. Pure, distilled potential. And how we choose to use it, that choice will shape the path forward. Your body softens. Your mind quiets. You are not thinking of equations anymore. You are thinking of the balance, of the delicate tension between creation and control. The same energy that could send a ship across galaxies could also unmake a city in an instant. It is not the power itself that determines the future. It is the hands that hold it. And as the night deepens, you are left with one soft thought. Before we chase the stars with a teaspoon of fire, perhaps we must first learn how to carry such power with care. Factories of the invisible, the night stretches around you like velvet. You are still, quiet. resting in the afterglow of distant stars and teaspoons filled with dreams. But now your journey moves inward, not to the vastness of space, but beneath your feet. Deep underground, far from sunlight, machines hum in circles. You are drifting toward them now, into tunnels curved like rings, lined with cold metal and magnetic force. You're entering the places where antimatter is not imagined, but made. These are the factories of the invisible. Places like CERN, the European Organization for Nuclear Research, sit beneath the Earth like hidden cathedrals of science. There, in the Large Hadron Collider, protons are accelerated to nearly the speed of light, whirling through 27 kilometers of vacuum and force. You imagine them now, tiny, determined, racing through darkness. And then they collide, not with chaos, but with astonishing precision. Controlled crashes at specific points, carefully monitored. When they meet, energy is released, not like thunder, but like the opening of a secret. In those moments, new particles are born. For a heartbeat, nature's rules are stretched. Among the debris, from the tangle of high-speed fragments, something rare flickers into being. Antimatter. Positron here, an antiproton there. Echoes of the early universe, particles not of imagination, but of reality. They are caught quickly, if at all, by the most delicate traps. Magnetic bottles that hold them suspended, not touching the walls, not touching the air, not touching anything at all. Because the moment they do, they vanish. You float now through these rooms, silent, sterile, alive with numbers. Screens glow with particle traces. Coils hum softly with superconducting current. Scientists whisper to one another in calm focus, tracking lifespans of less than seconds. They are listening to the universe speak in its smallest voice. These are not noisy factories. There is no clanking, no smoke, no fire. Only silence, spinning light, and intention. In one of these facilities, the antimatter factory at CERN, scientists have slowed down antiprotons, caught them, and combined them with positrons. They've built antihydrogen, atom by atom. Not much, just enough to study, just enough to prove it's possible. Antihydrogen, a mirror image of the first element. A ghost reflection, balanced and whole but made from the other side of the equation. You feel the quiet reverence of it. This is not industry. It is art. Precision work, guided by curiosity, patience, and wonder. But it is also hard. The cost, the time, the scale, it all adds up to a truth. We are still at the beginning. Creating antimatter is incredibly inefficient. For every billion collisions, only a few particles are formed. Holding onto them is even harder. And storing them for later use? That's still a dream. You think of it like catching snowflakes in fire. The systems required to even glimpse antimatter are vast, multibillion-dollar machines that stretch for miles and drink electricity like oceans. And yet, from them we harvest only atoms. Just atoms. And still we continue. Because even in the tiniest flicker, there is knowledge. Studying antimatter helps us understand fundamental forces, the push and pull that shaped the universe. It teaches us how particles behave, how they change, how time itself might tick differently in mirrored forms. Some researchers even study antimatter to probe the mystery of gravity. Will antimatter fall the same way as matter? Could it rise instead of sink? The experiments are careful, slow, but they whisper of secrets no one else has heard. You are floating now through the tension of it all. The dream of power, the reality of limitation. There's a poetry in the contrast. Machines so large, built to touch something so small. People working for decades to study something that vanishes in milliseconds. This is the nature of true curiosity. It does not rush. It listens. It waits. Tries again. And you realize, these factories are not just places where antimatter is made. They are where questions take form, where thoughts become tests, where the line between imagination and reality begins to blur. In one room, a technician leans over a console. Their eyes trace the delicate path of a particle in a cloud chamber. You imagine what it must feel like to see in real time the signature of an antiproton. Perfect curve. A footprint of the invisible. Not every experiment works, Not every answer arrives. But progress is not always loud. Sometimes it is quiet and steady, like a heartbeat beneath stone. And so we continue to build. Better magnets, better traps, cooler vacuums, tighter rings. Each innovation a step toward what may one day be possible. Not just the creation of antimatter, but its control. Perhaps one day the factories will change. They'll be smaller, more efficient. Perhaps orbiting the Earth where containment is safer. Perhaps built into ships, labs, even cities. But for now they hum below us. Patient, persistent. And in their humming there is hope. You rest here in this thought, held in the space between potential and limitation. The road to antimatter is long and full of obstacles. But every flash, every trace, every curve in the chamber tells us it's not impossible. You remember the teaspoon, you remember the light, and now you see where it begins. In tunnels, in silence, in places built not to create weapons or wonder, but to understand. And as your eyes grow heavier, and your thoughts slow to a gentle rhythm, you feel the pull of the next question rising, soft and slow. If these glimpses are real, if the antimatter exists, what would happen if someone imagined using it not to build, but to break? War dreams and fictional fears you lie quietly now, your body warmed by rest, your mind unfolding like soft pages in the dark. Behind your closed eyes, the world is still, but your thoughts drift onward, deeper into the question of power. And tonight, the question is not how antimatter exists, but how we imagine it. Because for all the precision of the labs, the care of the scientists, and the slow-building facts, there is another world where antimatter lives, a world of stories, fears, and dreams. It begins in fiction. You float now into pages of old science magazines, faded novels, and whispering films. In them, antimatter is no longer a fleeting spark. It becomes a weapon, a tool, a source of unimaginable destruction. A single gram, they say, could flatten cities. A tiny sphere could vaporize continents. You see it in Star Trek, where antimatter powers starships through the galaxy. You see it in thrillers, where antimatter is stolen from laboratories, placed in bombs, and hidden beneath cathedrals, ticking toward catastrophe. These are not gentle stories. They are fast and bright, pulsing with urgency. But still, they leave their mark. A seed of thought is planted. Could this be real? Could antimatter become the weapon of the future? The idea lingers in the corners of science, too. Military studies have been written quietly, carefully, wondering whether tiny amounts of antimatter could trigger nuclear reactions or serve as ultra-compact energy sources for weapons too small to detect. No fuel, no casing, just energy released in a whisper. And that's what makes the idea so haunting. Not because antimatter is easy to weaponize, it isn't, but because it could be one day. You float now between these thoughts, between imagination and concern. Antimatter is not uranium. It is not something that lies hidden in mountains or oceans, waiting to be found. It must be made in tiny amounts with effort, time, and staggering cost. But the possibility, however distant, sits quietly in the background of modern dreams. And the danger is not just in the making, but in the myth, because stories spread faster than science. Fiction writes headlines more easily than physics. And fear is quick to bloom in the minds of those who know just enough to wonder, but not enough to understand. You see this now, gently, without judgment. Fear has always followed power. From fire to fission, every discovery has brought with it a shadow. And so we imagine antimatter bombs not because they exist, but because we fear they could. Still, the truth remains soft, grounded, and reassuring. As of now, we cannot create enough antimatter to fill a grain of dust. We cannot store it safely outside laboratory conditions. We cannot weaponize what we cannot even hold. And perhaps that is a mercy. You contain opposites, too, and still you remain. Maybe that's the quiet lesson hidden inside this whole strange subject. That you exist because of imbalance. Because something tipped the scales. Because something stayed when it could have vanished. And maybe that's more than science. Maybe that's meaning. You lie in the dark now, and the room feels bigger than before. Not because it changed, but because you see it with new stillness. Every quiet object around you, your blanket, the air, the walls, is made of matter that once could have been nothing. You could have been nothing, but you are here, and you are made of stars, and you are made of questions, and you are made of particles that never touched their opposite and so became the world. There are still mysteries. We don't know why the mirror cracked. We don't know how to hold antimatter in our hands. We don't know where it has gone, or if it waits for us somewhere in the universe, hiding in balance, waiting to be seen. But maybe, for now, we don't need to know. Maybe it's enough to simply rest in the wonder, to feel the hush of knowledge wrapped in poetry, to breathe slowly, deeply, and know that your breath itself is evidence of matter enduring. And if, one day, we learn how to store it, how to use antimatter not for destruction, but for light, for healing, for exploration, for the quiet fire of knowledge, then perhaps we will have earned the right to touch the mirror again. But tonight, you don't need engines or experiments. You need only this moment, this pause, this peace, this awareness that you are part of something vast and real and impossibly beautiful. Not a bystander, participant. You are not separate from the universe. You are the universe briefly aware of itself. A spark that wonders, a molecule that asks, you are what remained, and that is everything. Thanks for watching. Please subscribe, like, and share. See you next time.